The way I look at dimensional analysis is that it's just a series of fractions multiplied by each other. And the key thing to these problems is to make sure all your units match up, and then at the end you just multiply your numbers across the top and across the bottom. So what is the purpose of dimensional analysis? Well, you're converting one form of measurement to another form. So in dimensional analysis, you're taking some measurement, whether it's 50 miles per hour, 2 gallons per minute, or 100 pounds per square inch. And you're taking these measurements and you're rewriting them, converting them to some other kind of measurement in Japanese. Just kidding. Okay, so after you do your conversion through dimensional analysis, you conclude with 73.3 feet per second, 32 cups per minute, and 13,789.5 Pascal that correspond to those three quantities on the left side. So in this tutorial, we're going to use three main steps here to do the dimensional analysis. We're going to learn how to match up the units so that they cancel out mathematically. And then from there, we multiply across the top and the bottom with numbers to get our final answer. Okay, so the fastest human has been clocked at 40.8 feet per second. This is a speed we don't usually comprehend because we understand speed mostly through what we see on the road, which is measured in miles per hour. So the first question, we are going to take this 40.8 feet per second and convert it into something miles per hour. Okay, so the fastest human travels 40.8 feet per second, and we can convert that to miles per hour. Now, I'm going to go ahead and tell you the answer to this is 27.8 miles per hour. How do you get there? Well, what goes in between these two fractions is a series of fractions that we call forms of 1, where the quantity in the numerator is equivalent to the quantity in the denominator. For example, 60 minutes over 1 hour, or 12 inches over 1 foot, or 5,280 feet over 1 mile. These are all what we call forms of 1. We're going to move from the left side of the screen to the right side of the screen. The top on the left side is feet, and the top on the right side is mile. So somehow we need to convert the feet into mile. The bottom on the left side shows second, and the bottom on the right side shows hour. And here, we also need to convert second into hour. There is a relationship between feet and mile, shown here in red, that there's 3 feet in 1 yard, and there's 1,760 yards in 1 mile. So we're going to use these numbers here. To cancel out feet on top here, basically our next factor, this fraction, needs to have a feet on the bottom also, to mathematically cancel it out. We're going to convert from feet to yard to miles in the next few steps here. And our first factor here is going from feet to yard. Okay, and the way we place the feet on the bottom allows us to cancel with the feet on the top of the previous factor. At this point, the unit that's left on top is yard, which still does not match mile, which is what we need at the end. Just like before, we need to cancel out that yard on top. So we introduce a yard on bottom on the next factor. Working toward the end, we now throw in the next factor that links yardage to mileage. And with the yardage canceled out, the unit that left on top is now miles, which matches what we need. Okay, so at this point we're halfway done because the numerator is already matched up. Now we need to figure out how to go from second on the bottom here to hour on the bottom. Since second is on the bottom, to cancel it out, we need a second at the top for the next factor. And so that's where we place in the next fraction of second over minute. With that new fraction, the seconds canceled out, and then now what remains on the bottom is the unit minutes, which does not quite match to hour. We still need to work toward hour. Okay, so now we got to cancel the minute on the bottom with the minute on top for the next factor. So we throw in the factor that's minute over hour. And now we make our linkage to hour. The minutes canceled out, which is what we want. And so now let's check. What are the units we made? Hours versus hours. Okay, so let's quickly check to see what we have here. On the left side, you got all that mess, but all the units canceled out except for mile on top and hour on bottom. And that's exactly what we want because it's shown there on the right hand side. Now we put in all the numbers into the fractions. And now we can also multiply across the top and then across the bottom and simplify, and there's our final answer, 27.8 miles per hour. And if you want, you can shorten this process down. Here I'm showing on the second line that you can actually merge two of the factors together. You can go from feet directly to miles, and that will sort of delete one of the factors for you. You can also go straight from seconds to 1 hour. So we learned from this problem that maybe we don't understand what 40.8 feet per second is, but through dimensional analysis we understand now that it's 27.8 miles per hour, and that's how fast a human can run. Okay, now time for a practice problem. Suppose the bathtub is filling up at a rate of 240 gallons per hour. What is that speed in cups per minute? If you want, go ahead and press the pause button and try this problem on your own, and then resume the video when you're ready to check your answer. Okay, so first thing I did is I talk about the units without the numbers and see what cancels out and work toward a certain unit. That meaning I'm working toward the cups on top and working toward minutes on bottom. Then I plug in the numbers and calculate the final number after that. Okay, and I want to just close with the summary of all the steps that we went over today. Step 1, figure out the units cancellations first, match things up, cancel them out, and then plug in the numbers across the top and bottom, multiply them, and of course simplify at the end. Of course the calculator can do that for you.